Hello guys, welcome to my YouTube channel. Today I Abhijit is back with another video on deepfake detection project. In earlier videos we saw how to install a Django application in your machine, and in one of the video I also explained the workflow of the project, what all things are needed, what the project is doing. So in today's video we will look at the model creation. So in today's video, we will cover how we can create a defect detection model.
Today we will look at this model creation. Today we will create a model from scratch by doing all the pre-processing, creation of model and predicting the model. So we will be using Google Colab for this. It is recommended to use Google Colab because training a model on your own machine has its own set of challenges. So first of all, we will start with gathering the dataset. So I have used three types of datasets here. First one is from Face Forensics Plus Plus. Second one is Celebrity Deepfake dataset, and third one is Deepfake Detection Challenge dataset. So I will show you how to download these datasets. So first we will take a look at Face Forensics Plus Plus dataset. So for downloading these datasets, I have given the links in the readme of the project. So go to Face Forensics Plus Plus, and here you can see that you need to fill this Google form. So after filling the Google form, the Face Forensics Plus Plus team will send you a code and steps how to download this dataset, and after that you can be able to download the dataset. The same applies to the celebrity defect detection dataset also. You need to fill this Google form and then you will receive a link from them to download the dataset. So I will not do this. I will just go with defect detection challenge dataset as it is easily available. You can directly download this dataset. So you can see there are various parts of the dataset. Around there is 471 GB of data is available. But there's an important point to note that in this dataset there are some videos that are audio altered. So that audio altered video might not be a good video for our project of defect detection because we are only considering the videos for this. So you need to filter out that audio altered deepfakes. I will tell you how to filter these audio altered deepfakes. I have also created a program to filter these audio altered deepfakes. You can use this program and filter the audio altered deepfakes. So first of all, I will download this uh, dataset. I recommend using the face forensics and celebrity defect dataset because there are no audio altered videos in this. For this dataset, you need to do some extra steps. Also, this dataset is very much realistic looking, so training this is a little bit difficult task. So I will download one of this. It is asking me to sign in. I will sign it with Google. So you can see that it is downloading. I will pause the video till the dataset gets downloaded. So now I have downloaded this dataset. So we will extract the dataset. I will extract it here only. So till the time the dataset is been extracted, I will show you how the Face Forensics Plus Plus sends the link. So they will email you a code like this. This is the code that will be used to download the dataset. For executing this code, The instructions are provided by face forensic plus plus here. You need to go to that link and you need to go to the download section. So after going to the download section, here they have mentioned what all folders or directories are there. Here they have mentioned how many videos are there, what is the encoding type, how much is the size if you download it as raw at 23 or at 40, C40 or C23. So here they have provided the commands. Like you need to just provide the output path to download all videos at C33. You can pass the number of videos also. So they have given a good documentation here. You can follow this documentation, execute, and the dataset will get downloaded. So I will check if the videos are extracted. Now the video, you can see that videos are extracted here. So with every video there is a metadata.json. This JSON file contains the metadata of the video, that whether the video is fake or real. Like you can see here it is given as label as fake, where it is a train video or test video, and the original video from which it has created this deepfake video. So this data is available here. So first of all you need to convert this to a CSV file, because we are dealing with a CSV file in our code. So for converting this to a CSV file also, I think I have a code for this also. Okay, yeah, here you can see that label JSON to CSV.py. So this will help you converting the video from metadata.json to metadata.csv in the required format for the code. So now we will start running our project. I will give you a whole code walkthrough. I will not be explaining each and every line of the code, but I will explain what exactly that piece of code is doing. So first thing we need to do is to so I will not uh, consider all the videos. I will consider some videos for just a prototype purpose. So I will copy some videos to another folder. So I will deal with some videos only. Before that, you must filter out audio filtered video from this. I will You need to then archive this file. You need to archive it in a zip folder, zip format, sorry. So now you can see that the videos are archived in a zip format. After that you need to upload this video to your drive, because we will be mounting the drive on a Google Colab environment. So now copy this zipped dataset to drive. Till the time the dataset is been uploaded, I will show you further steps. Now you need to download this project. Either you can download this project and then upload to Colab, or you can directly just clone into Colab. But I will recommend it downloading and then uploading. It is a one-time activity because Colab saves the data. Just go to Colab. Now you can upload the collab file here. So I have already cloned this file. Here you can see I have cloned this. Go to model creation. First we will start with pre-processing. So there are first we will do the pre-processing, then we will train the model, and then we will predict the data based on the trained model. So first we will look at pre-processing. So you can see that the pre-processing step has been pre-processing notebook has been opened here. So I will change it to a dark mode. So now first thing that you have to do is to mount your Google Drive here. Just run this file, run this cell. So it is connecting now. It will allocate a instance in the backend. So just click on this link, select your Gmail account, then you need to paste this code back to your collab. Paste that code here. So after this you will see that a drive has been mounted here. You will be able to see your drive's data here. This was the data set that we have uploaded to Google Drive. So now before running anything, we need to change the runtime to GPU, because currently this collab is using the CPU. So for our project the CUDA is mandatory, so we will switch it to GPU. Go to runtime, change runtime type. So actually it is in on GPU only, but you can see that sometimes it is on CPU. You need to change it to GPU. So now we need to pass the ID of the file, Google Drive file. For example, so if you go here, click on share, get a link, just paste the link here, comment that link, and copy this ID and paste it here, replace it here. Now run this. So what this code is doing, this is copying that file from there and unzipping that file here. Since there is some issue with the zip file, now we will apply another approach. In this approach, you need to directly upload the folder of the dataset to the Google Drive. So you can see here I have uploaded the dataset folder here. So after mounting the drive to the collab, you can see that in drives, my drives folder, you can see a dataset folder here. You can do another approach. You can directly upload files to the session storage, but there's a problem in that. So like Google collabs get disconnected in the middle sometime during working, so you can lose your data. So I recommend uploading it to a Google Drive so that you can not lose the data, and the data becomes persistent. So now I need I recommend you to skip this step, because if it's work for you, then it's well and good. You can apply this method also. But for me, it's not recognizing that zip file. Maybe it's not zipped correctly. So here what the code is doing? It is means it is counting the number of frames from each video. It is giving us the total number of frames in the video and the average frame per video. For example, if we have 10 videos and each video is having 300 frames, so the average is 300. So it is calculating the average. So this average will help us later to decide how many frames we will going to uh, consider for our video. So now I need to change this path. Currently I am in content, so I will go to drive slash my drive slash data set, and then we will consider all the videos in this directory. So all this video will be considered. So let's run this. So now it is doing processing. It will check one by one each video and will count its frame and will give you total number of videos and the average number of frames per video. So it will take a bit time depending on number of videos. So currently I have passed a small number of videos, so it has executed fast. So if you take too much videos, then it will take time. You can also go, you can also combine two different folders and pass it to a single variable and then iterate through variable and check the number of frames. So you can see that currently these are having 299 or 300 frames. So total, let's see, there are 16 videos and average is 299. So being a safe side, we will consider only 150 videos while creating a new data set. So here we are extracting each frames. So you can see we are extracting each frame from a video. Here we are installing a face recognition library, and here we are creating a new directory in our drive. So I will just rename it to face only data, and we will crop these videos along the face and write it to this directory. So this function is doing the same thing. It is extracting each frame. This method is used here. It is extracting each frame. We are considering 150 frames. So we will be writing only 150 frames to the new video, and it is cropping the face. So this code is responsible for cropping the face along this. So you can see that bottom, top, left, right. So we are recognizing the face by the face recognition library. So here we are getting the locations of the face and we are passing this face location here. So now I will run this code. So basically it will create new directory in our drive and will install the required libraries. So it is now installing a face recognition library. This is the one-time activity. When your session is open, if your session is closed in between, you need to again do this activity. So now it has been forwarded and you can see that there is a new folder has been appeared on your drive. This is face only data and currently it is empty, so we will be writing all the face cropped videos here. So let's start writing the face cropped videos here. So this method will do that. We are calling create face video. This create face video method here, we are passing the path, list and the output directory. Well, actually there is stake here. So our output directory is face only data that we have created above. one. Instead, you can just copy this path and paste it here. I will terminate this and run this again. Also, there is so this method is, you can see, persistent method. So it will all checks whether that video is already present or not. If that video is already present, so it will not process that video again and again. Now you can see that 6% has been processed, means one video has been processed. So now if I stop this method and try to rerun this method, so it will check whether that video is already present. So you can see that the uh, this video is already present. So it will skip that video and go to another video and try to and create a face crop video for that. So this will help you for processing a very large data set. So you don't need to process that video again and again. So till the time the videos get processed, I will pause the recording. So now you can see that the processing has been complete. To speed up this process, you can do one thing. You can decrease this 150 to 100 or to 50 according to your need. So basically, it will write 150 frames to a new video, new phrase crop video, I will say. So by decreasing this 150, you can speed up this process. So this processes elapsed 12 minutes and 52 seconds. So now can see that the face crop videos have been generated here in the face only data. So I will download one dataset and show you. Uh, Basically use VLC media player to view this video. Other media player might not support that. So you can see that these are the frames that are cropped from the original video. So now the next, so we are done with pre-processing. In pre-processing we took an original video and generated a new video that is phrase cropped and that has less frames so that it can be easy for us to process the video. Now we will move on to the next part, that is training the model. So so you need to upload this CSV now. So this Jupyter notebook file now, model and train CSV. So I will upload that file. Basically I have already uploaded that file. I will just select that file, but you can upload that file from the upload menu. So now we need to again follow the same step. We need to mount the drive and then load the videos and then train the videos. So first of all I will mount the drive. It is showing there are many sessions open. I will terminate one session. Basically, I will check the runtime first if it is on GPU only. It's on GPU only. Let's mount the drive first. Click on this link, select the, copy this and paste this authorization code here. So I will not use this as our videos are not in the zipped format that are currently available on drive. So we will install the face recognition library. Now this code will check whether the video is corrupted or not. Now what happens when we do pre-processing? Our video sometime gets corrupted while writing. So sometimes our video get corrupted while pre-processing. So to avoid such further issues in the videos, so in the to avoid further issues, we will first of all check whether that video is corrupted or not. So basically, this validate video function will check whether that video is corrupted or not. This will use this frame extract to extract one and on each frame. This is for normalization. These are standard values of PyTorch. So I have used the standard values only. This will convert the video into tensor. Basically, this will to convert each frame into a tensor. So these are the video files that you need to consider, and this code will run the validate video function and print whether any video is corrupted or not. So in our case, we are loading the video in face only data. So we need to change this to face underscore only underscore data. So I will remove rest of this because we are considering only one folder this time. So let's run this. So currently there are total 16 videos. These are the path of this video. So it is showing that number of videos processed are 2 and remaining are 14. So corrupted video is, so now our code has identified that this video file has been corrupted. So basically we will delete this video file from this uh, drive. So you reprocess this video file, but it will be very lengthy task, and reprocessing each and every corrupted video file is not a good approach. So rather I will delete this file directly. So this is AQP, APQP, and okay. So this one is corrupted. So I will remove this. I will refresh the drive and check if that file has been deleted or not. Yes, it's deleted from here. Now I will again run this file to check whether any other video is corrupted or not. So now there's zero corrupted videos. Now we can proceed further. So this code is loading the video into memory. So I will again copy this and just paste here. We'll delete the rest of that. So basically we are shuffling the video files and then loading it to memory. So now you can see that average frame is 147 frames. That we have selected 150 frames, but our code doesn't write all the 150 frames. So there are inconsistency in writing the frames. So the average is 147. So now we will load the video names and labels from CSV. So this is the global metadata CSV. So you need to have one CSV uploaded to the drive for this. So I have created one global metadata CSV in which I have added all the file labels that I worked on. So I will check if these files are available in this only. Also, so here it is global metadata. I will upload this. Upload a OneDrive. So this is file has been uploaded here. So the path is looks correct. So I will run this. So basically what it is doing, it is just means it is loading the video and the labels to our tensor. This is extracting each frame, and it has assigned, it is basically, you can say, it is encoding the data. It is encoding where if it is a fake it is encoding to 0, and if it is real it is encoding to 1. And uh, this function is plotting a tensor of that frame. So this this function will count the number of real and number of fake videos. So this is function is not called yet. When this function is called it will count. So we are loading the labels from here. We have set the headers. We are considering 80% of the 80% of the data as trained video, and rest remaining 20% as a validation video. So you can add one more thing of a test video. We are considering validation video as a test video here. You can add one more thing and you can split it to 70, 20 and 10. And here there's one important thing to note, this sequence length. So this sequence length will decide how many frames you are going to process. So currently we are at processing the 10 frames. This means that the first 10 frames will be passed to the model for training, and here batch size. So it is very hard to process all video at once. So we are processing that videos in the batches. So currently batch size is 4. So there will be 4 videos in a single batch. So we will be processing a batch wise batch. So there are 12 now. It is classified as 12 as train and 3 as test. So train and test. So there is no real video in this. All videos are deepfake. So that's not a good candidate for us if we consider all videos are deepfake. That's why there is an index out of bound error, because this there because in the validation video list there is no file, so it is giving us an index out of bound error. So I will upload a real video here and we'll try once again. So to fix this error I will add some 2 or 3 real videos from that metadata, checking that metadata.json, and preprocess will preprocess that and will come back. Added some real videos to the dataset. You can see that there are 4 real videos and 16 4 real videos and 16 fake videos. So in trained dataset there are 4 real videos and 12 fake videos. In test dataset there are no real videos and 4 fake videos. So for me this is the scenario. For you the scenario will be different, because I am doing this on a very small number of videos. That's actually there are 20 videos only. So for this the accuracy may not be good, or the model may not behave as expected. But if you do it with a large number of data set, then it will work fine. It is recommended to use 50% real videos and 50% fake videos, so that the model does not get biased. So now you can see that the data loaders loads the labels and the videos into the tensor. We have plotted one image from one random video. So this is the model with feature visualization. So in model we are using a ResNext model, residual network CNN. To means ResNext will help us to perform very deep operations in a good manner. We are using one sequential layer. With that we are using LSTM. We are using a leaky ReLU layer for normalization. We are using one dropout layer, and there are various different layers. This is the forward propagation of the model. We are now downloading the model and fitting the model. We'll run this first, and then this. So this is a train epoch and this is the test epoch. We are creating a checkpoint.pt for saving the model. We are just printing some of the things on the console. Let's run this. This is the method to output a confusion matrix. This is to plot the loss. We will be plotting a loss at the end. So this is this this is where our actual model is getting trained. So we are using an Adam optimizer for training the model. So currently our learning rate is 0.01. So you can play with the learning rate and change it needs according to your needs, where the gradient descent minimizes lo- converges to a local global minimum correctly. So you can try increasing or decreasing this learning rate. So currently I have set it to 001. So my model performed better at this learning rate. So we are using cross entropy loss for this. So I will run this. uh, so actually I have printed the name of the videos. So if you don't want to print the name of the video, then it's okay. So I will comment the name of the video and will run this again. Let me terminate this. Okay, here it is taking the name of the video from here. Let's run this again. Okay, so now you can see that the model is getting trained. Currently the accuracy is 100%. This is weird, I know, but in the dataset you used, it is completely a biased dataset. It is not a well balanced dataset. So that's why it is giving accuracy of 100%. Even it is, so there are, it is using 4 batch just for each thing. So actually it is not stepping. The gradient descent is not even stepping, it's just the same. So changing the learning rate might help in this, but I'm showing this for a demo purpose. So you can see that the accuracy is decreasing. I will pause this video till the time the model gets trained. So now you can see that the model has trained. These are the training and validation loss. You can see that they are continuously decreasing, but the accuracy in this case is, training accuracy is increasing, but validation accuracy, since we don't have any real video in the validation data set, so the validation accuracies will remain 100. And yeah, I know that's weird, but since we don't have any real video, this is happening. So if you have a real videos in the validation datasets, then this will change. And as we don't have any real videos in this, so the model is not able to plot the confusion matrix for this. So if you add any real videos, so model will surely be able to add the plot the confusion matrix. So now you can see that the checkpoint.pht is created here. We will download this video for our, so we will download this trained model for our prediction purpose. So now I have downloaded that checkpoint.pt. Now next step is to upload this checkpoint to your drive. So I have uploaded it earlier. So this is my checkpoint.pt. So now we will run the final step of our project, that is to perform the prediction. So we will pass a fresh new video to the model and check if our model is uh, predicting that accurately or not. Let's upload a Jupyter notebook. Go to your GitHub and upload the final predict Jupyter notebook file. It's getting uploaded. Now the story is again simple, just we need to mount the drive. It's telling that I have too many sessions open. I will terminate my earlier session and open a new session, because Google allows only one session per account. So if you want to do pre-processing, you can use multiple Gmail IDs and do pre-processing at one time for a huge amount of data. So we will import the libraries first. So this code is totally picked from the more training part. So in training part we have the exact same code that has a class of a model with the different layers. This is for a prediction. This is the new code that is been written. This is for prediction. We are just predicting it. We are loading the weights and predicting it. This is the validation dataset, so this code is also the same, and this is also the same. Just we need to pass a part to video here. So I will run all this. So now we need to pass a video that we need to pass for prediction. So since I don't have any videos uploaded, I will use my old videos only in the dataset. Just let's pass this video. So our drive, we have a data set folder. After that we have a video, and for this we are using checkpoint.pt. So we will start the prediction. It is downloading the Resnex model. Okay, there is some issue with the path of the checkpoint.pt. I will recheck the path. It is in my drive. Let me check here. It is in drive, my drive. copy the name from here. It is in content drive, my drive. Oh, it's not in the models folder. It is in just in my drive. Let's run it again. And one thing to note that we are using a 10, we have trained the model in 10 sequence length, so we must use 10 sequence length here. If you use 20 also, the model will predict it, but it's always good practice to use 10 frames here only. Let me run this again. Okay, so model has classified this video as a fake video with a confidence of 76.95. So this way you can predict the videos. You can pass any new videos downloaded from here. And so this is an optional thing. This is used when you need to pass the full frame for prediction instead of face crop frames. This means that now you can see that this is a face crop frame. This is cropped around the face. If you need to pass the whole frame to the model, you can also do that. Just copy this code and just replace this validation dataset, this validation dataset method, so you can pass the full frame to the model. And you need to do that during training also you need to pass the whole frame, so there is no need of doing no, in pre-processing also you need to pass the full frame. If you need to pass the full frame, I don't think there is any need of doing pre-processing. You can directly load the model, directly go to model and train and pass one frame each time and achieve this. But I recommend using the face crop frame, because if we pass the whole frame, so model will get confused that which features to look at when for prediction. So it will not consider frame, it will consider all the background also, so model will be little bit confused. So it is recommended to use face crop method only. So by doing this you can achieve, you can predict whether the video is a deepfake video or a real video. So that was it in today's video. Thank you and have a nice day.